Hello dear all. Today we are going to discuss about Ohm's law. In 1827, a German physicist George Simon Ohm stated a law that the current flowing through a conductor is directly proportional to the potential difference applied across it, provided the temperature remains same. This means V is directly proportional to I, where V is the potential difference applied across the conductor and I is the current flowing through the conductor in the circuit. When the V increases, the law states that when V, the potential difference applied across increases, current flowing through the conductor in the circuit also increases. V increases, I increases. Let us switch on the circuit and see a steady current I flowing through the conductor in the circuit. And let us see by increasing the potential difference applied across the conductor. We have increased the potential difference applied across and switch on the circuit again. The current flowing through the conductor in the circuit is also increases. The law states that when V increases, I increases. When V decreases, I also decreases. Or this can be expressed a relation V equal to IR. Where R is a constant called resistance of the conductor. Now, what is this resistance? A resistance is a property of a conductor which opposes the flow of electric current in an electric circuit. A resistance can be drawn as in the figure. This is the image of a 12 ohm resistance commercially available. To understand the definition of the resistance, we can connect a resistance in the circuit and see the changes in the current flowing through the circuit. As soon as we switch on the circuit, Ssrd current flows through the valve in the circuit. Now we connect the resistance in series with the valve in the circuit and switch on the circuit and see the changes. As soon as we switch on the circuit, we can able to see that the flow of electric current in the circuit is opposed by the resistance, and thereby the current flowing through the circuit gets slowed down. Similarly, the valve that connected in the circuit is also getting dim. SI unit. A resistance is measured in ohms. It is symbolized by the Greek letter omega. The resistance of a conductor depends on two factors. It is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area of the conductor. A conductor of resistance R having a length L and cross-sectional area A. Resistance R is directly proportional to length L. That is, R is directly proportional to L and R is inversely proportional to cross-sectional area A. As the length of the conductor increases, the resistance of the conductor also increases. And again, as the cross-sectional area increases, the resistance of the conductor decreases. Or we can write simply R is proportional to L upon A. Or the relation can be expressed R equal to rho L upon A, where rho is a constant called resistivity of the conductor. The resistivity of a material is defined as the resistance offered to the flow of current by a conductor of unit length having unit cross-sectional area. That is, when the length of the conductor L equal to 1 and the cross-sectional area A of the conductor is equal to 1. The SI unit of resistivity is ohm meter. Resistivity increases linearly with temperature, but it does not depend on the length and cross-sectional area of the conductor. Now let us understand more through few examples. Example 1. How much current will draw by an electric bulb of filament 1 kilo ohms from a 230 volt supply source? We are given here V equal to 230 volt and R equal to 1 kilo ohms, which is equal to 1000 ohms. By the Ohm's law, V equal to IR or I equals V upon R. We simply put the value of V as 230 volt and R 1000 ohms, and we are getting a current of 0.23 amperes. Second example. A heater draws a current of 5 ampere from a source of 120 volt supply. How much current will draw by the same heater if the supply voltage increases to 240 volt? We are given here V equal to 120 volt and the current I equal to 5 amperes. By the Ohm's law, V equal to IR or R equals V upon R. We simply put the values of voltage 120 volt and I 5 amperes, and we are getting 24 ohms. The value of resistance is 24 ohms. When the supply voltage is increased to 240 volt, then again applying Ohm's law, I equals V upon R, where new V, the value of V is 240 now. We can simply put the value of V as 240 volt, and we already calculated 24 ohms resistance and put this, and we are getting 10 amperes. We can understand more through the example 3. A wire of a given material having length L and area of cross section A has a resistance of 4 ohms. What would be the resistance of another wire of the same material having length L by 2 and area of cross section twice A? For the first wire, R1 equals rho L upon A, rho L upon A, which is equal to 4 ohms already given here. Or this can be put rho equal to 4A upon L, and we take this as a equation 1. For the second wire, L2 equal to L by 2 and A2 equal to twice A. R2 equal to rho L2 upon A2. We know the value of L2, that is L by 2. We simply put the value in rho L2 by A2. The value of L2 is L upon 2, and put the value of A2 as twice A. So the value of R2 is rho L upon 4A. Since the resistivity rho is same, we simply put the value of rho from 1 in equation number 2, and this we are getting 1 ohm. So this is all for today's class. Let's see you in the next class.